Let's look at a similar example. Let's ask the question, what are all the solutions to 2 tangent squared of beta times sine of beta is equal to square root of 3 times tangent squared of beta for beta less than or equal, greater than or equal to 0, but less than 2 pi. So this looks very complicated, but we just need to keep our general process in mind. So first we need to remember that we can use the unit circle to our advantage. Again, if we can get sines and cosines equal to a specific number, we can use the unit circle. Likewise, we can use algebra to decompose the equation into parts, so this will make it a little more simple. And lastly, we also have to check our domain. Sometimes we can manipulate things with algebra and we introduce a solution that doesn't make sense, like maybe we're dividing by 0. So we need to make sure that each of the solutions actually makes sense. So let's go to the board. So here we have our equation. We have 2 tangent squared of beta times cosine of beta is equal to the square root of 3 times tangent squared of beta. So while this is very tempting, you might want to divide by tangent squared of beta. But this is not going to be a good chance because we can actually lose solutions. So what we really want to do is try to factor. If we get everything to one side and factor it out, we'll make sure that we preserve all the solutions, that nothing disappears in some way. So let's do that. Since we want to factor this guy, let's move all the tangent, this square root of 3 tangent squared of beta all over. So what do we have? We have 2 times tangent squared of beta times sine of beta. And now we're subtracting this square root of 3 tangent squared of beta. And that's all equal to 0. So now that we have this, all of our mess on one side, if we can factor it apart, we can look at each of those factors, and one of them has to be 0, since we're multiplying to get 0. So if we just investigate this, we can actually see that both of these terms have a tangent squared. So what we can do is just factor it out. We don't have to do tangent squared minus anything. These are just factors of every single term, so let's pull it out. And I'll write that in red just to keep track of it. So we have tangent squared of beta all times whatever's left. So we have this 2 here still. We pulled out the tangent squared of beta, so we don't need to worry about that. And then we have this sine of beta. And we're subtracting whatever's here, but remember we pulled out a tangent squared of beta, so this is gone, and all that's left is a square root of 3. And that's all equal to 0. So, when could this possibly be the case? Could this be the case? What values of beta are going to satisfy this equation? This is going to have the same solutions as this, the original question, so this is worthwhile to do. So let's just mess with the first one. We have that tangent squared. One option is that the left side is equal to 0, so tangent squared of beta could be equal to 0. So what are we going to do? Well, we have tangent. This is really just tangent of beta squared. So what number squared is equal to 0? There's only one of them, and that's just 0. So this is really equivalent to tangent of beta being equal to 0. And maybe you don't remember how tangent works. You don't know the values of tangent. So what we can do is rewrite this in terms of just sines and cosines. So what is tangent of beta? Well, that's just sine of beta over cosine of beta. And that's all equal to 0. So lastly, when is a fraction equal to 0? Well, only when the top is 0. So our final spot is that we're looking for sine of beta to be equal to 0. So one possible solution is when sine of beta is equal to 0. And let's use the unit circle to figure out what those solutions are. So when is sine of beta equal to 0? sine is the y-coordinate, and we're also only looking from 0 to 2 pi, so therefore we only care about the actual unit circle, which is very nice. So when is sine equal to 0? Well, when the height is 0, well, here's one point, and this is 0 or 2 pi, but we're including 0 because this is less than or equal to, and we're not including 2 pi since this is less than. So 0 is one solution, and likewise pi is the other solution. So let's write that down. So here we have beta is equal to 0 or pi. This is one possible solution. Let's look at one more. The other option, we have either the left expression that was factored out is equal to 0, or the remaining part is equal to 0, because this is just a big multiplication, this thing times this whole thing in the parentheses. So we're also asking, this will have another solution is when this left side is equal, or this right side is equal to 0. So when 2 times sine of beta minus the square root of 3 is equal to 0. Just like before, we want to solve for this sine of beta. So let's just use algebra to move everything over. So first of all, we get that 2 beta is equal to the square root of 3. And lastly, we divide by 2 to get that sine of beta is equal to the square root of 3 divided by 2. A nice thing is that we're looking for inputs that have an output of square root of 3 over 2. And this is actually something that we're used to. We're used to this being a typical output of sine and cosine. So we should be able to find this directly by using the unit circle. So let's figure that out. We're looking for sine of beta equals the square root of 3 over 2. So sine, so we're looking at the height. 1/2 is about here, and square root of 3 over 2 is even bigger. So it's somewhere around here. It's one of these two, and it's actually up to this height. It's as close as we can get to 0 to 1 for our typical inputs for trig functions. So here we have these top one. This one right here is the square root of 3 over 2. So that means sine of 2 pi over 3 is equal to square root of 3 over 2, which is one solution. And we also have the other side. So we have sine of square root of pi over 3 is equal to the square root of 3 over 2. And just by looking at this, these are our only two solutions from 0 to 2 pi. So those are our only other ones. Therefore, beta is equal to pi over 3 or 2 pi over 3. Okay. So all in all, what are our solutions? It's either these ones or these ones. So together, these make all of our solutions. And the other thing we have to be careful about is that we have a tangent here. Well, like we wrote before, tangent has is the same as sine over cosine, and cosine is a denominator of a fraction, that could be 0. So we just need to make sure that none of these values give us cosine equals 0. So it turns out the only typical angles that give us cosine equals 0 are pi over 2 and 3 pi over 2. This is neither of these are those, and neither of these are those either. So all in all, our solutions are beta equals, let's just write them in numerical order, so 0, pi over 3, 2 pi over 3, and pi. So therefore, all the solutions to 2 times tangent squared of beta times sine of beta equals square root of 3 times tangent squared of beta, when beta is between 0 and 2 pi, where we include 0, the only solutions are exactly 0, pi over 3, 2 pi over 3, and pi.